Okay, guys. Lesson 6.6 is function operations. I don't know if it's good or bad. Some of you will consider it good news. But we get to steer away from radicals a little bit. They're not going to be our big focus. We're still going to see radicals. As you look through, you'll still see radicals. But that's not what our focus is. It's more about how do we work with these functions. The front side of our notes is function operations. How do we add functions? How do we subtract functions? How do we multiply functions? How do we divide functions? Nothing that is too out of the ordinary here. And we're going to try and look at a few of these. And then the video you watched was more focused on function composition, which is on the back side of the notes. Okay? And I'm not sure, I don't know, having no introduction, I'm not sure how much the video made sense. But I was hoping it would do just that, kind of introduce it a little bit for us. So function operations. Basically what this is saying, guys, f plus g of x. If you're told to do f plus g of x, what you're being told is to take f of x, whatever that is, take g of x, whatever that is, and to add them. Okay? If you're asked to do f minus g of x, you're doing f of x minus g of x. If you're being asked to multiply f g of x, then it's f of x times g of x. Same thing with division. You will know with division, it does say given that g of x does not equal 0 because, what do we know about a denominator? Denominator can never equal 0. Okay, now, one of the, probably the harder part than doing these is we're going to talk about domain. So the domain of these functions are the x values that work for both functions. Okay, domain, x, that should already be known, right? Your domain are your x values, and they have to work for both functions. So if you take f and you take g and you divide them, it has to be x values that work for one and work for the other. And we'll talk about some examples there. And then also, just as a reminder, when using the quotient function, when we divide, we will have to exclude anything that would make your denominator equal to 0. Okay, let's look at example 1 here. Or example 1a, I should say. F of x is defined to be 4x plus 7. G of x is defined to be square root of x plus x. And notice that I will say in this example. Is that always what f is going to be and always what g is going to be? No, that's this particular example. This particular example then says what are f plus g and f minus g, and what are their domains. So let me walk you through this. First thing you're asked to find is f plus g. Official notation, you might see, and I can't remember exactly the notation Math Excel uses, but you might see as f plus g of x. Okay, be logical. How do we do f plus g of x? We're going to do f of x plus g of x. What is f of x? F of x is 4x plus 7 plus, what's g of x? Square root of x plus x. And you could have parentheses around these, but we're also just adding. So it's not that we have to have parentheses around these. Okay? Your key is how do we add pieces like this? We're looking for any like terms. Thank you. So what do you guys see here in the way of like terms? Okay, 4x adds to 1x. And what is 4x and 1x? 5x. Any other like terms? Okay, no other like terms. So at this point, it would just be about carrying the other pieces down. What are my other pieces I need to include? A 7, a plus 7, and a square root of x. Now, order-wise, I tend to put my variables first, so I'm actually going to say plus square root of x plus 7. Is it wrong if you did 5x plus 7 plus square root of x? No, not usually. Unless there is some restriction about the order you put them in, either would be fine. So right here, this is what I would put as my answer for f plus g. There's no other simplifying you can do. So we've done all, by adding our like terms, we've done all the simplifying we can.
So if there was simplifying, we'd have to.
Right. And yeah, you want to do all simplifying you can, but there's not necessarily always a lot that you can do. Okay, before we talk domain, let's go ahead and talk f minus g. And I think I can put it in here. We're going to try and make it work here. Okay, so what are we doing for f minus g? F is, again, 4x plus 7. And then what are we subtracting? We're subtracting square root of x plus x. Now, here's the deal, guys. There is an important set of parentheses that has to be there. On the plus, I threw in the parentheses. We didn't have to have them. On the subtraction, there are some parentheses you have to have there because we're subtracting everything in that second quantity. So if I go ahead and write it like such, it's the quantity 4x plus 7 minus the quantity square root of x plus x. The key is what is being subtracted? The square root of x is being subtracted, and what else is being subtracted? That x is also being subtracted. So that's the key you have to watch out for. So how does this change our answer when we clean it up now? Again, we're looking for like terms. What goes together? 4x and x still go together, but what's the difference now? This x is being subtracted, isn't it? So what is 4x minus x? 3x. What about your other pieces? You still have a plus 7, yes? And you have a square root of x. What's the catch with the square root of x, though? You're subtracting that square root of x. So this time when I write it, I'm not subtracting it from anything, but still I'm subtracting it, so I'm going to have a minus square root of x, but still a plus 7. So here for this answer, I have 3x minus square root of x plus 7. Okay. Nothing too fancy there, right? Basically, you're adding, subtracting like terms. Now, before we move on, though, we were asked to talk about their domains. So, as we talk about the domains, my suggestion is we talk about the domain of f, the domain of g, and then we'll put it all together. So, if I talk about the domain of f, okay, what was f? F was 4x plus 7. Are there any types of numbers that I can't put in there? Are there any types of numbers that I can't multiply by 4 and add 7 to? We can put positive, negatives, fractions, decimals. We can put them all in there, can't we? You can take any number you want, multiply it by 4, add 7. So my domain for f, I'm going to say all reals. There's no restrictions there. We'll talk about restrictions when we get down to like square roots and division and stuff. Now, forgot what I was saying here, where I was going. What about the domain of g? G was what? Square root of x plus x. Are there any numbers that I can't put in there? I can put it whatever I want in for plus x. But what about the square root of x? Can you take the square root of any old number you want? Not exactly. What kinds of numbers can we not take the square root of?
Negative numbers.
Negative numbers, right?
Yeah.
If you put square root of a negative number in your calculator, what's your calculator going to do?
Error.
It gives you some kind of error, right? Depending on your calculator. Now, can I take the square root of, say, 5? Technically, yes. It's not a pretty answer, is it? But will your calculator do a square root of 5? It gives you a big, long, messy decimal, right? So a number like that is fine. The numbers that aren't fine are your negatives. So what are the only values we can use for x here? They have to be positives, right? And so I'm going to write positive, so that is kind of the idea is in your head. Often when we talk positives, how do I express that with an inequality? Like with less than, greater than signs. What kind of numbers are positive?
Greater than 0.
Greater than 0, yes. Now, can we include 0 here? Can we take the square root of 0? Technically you can. The square root of 0 is 0.
But if you add 0, it'd still be 0, and it says that it can't be 0. Oh, wait, no, that's.
Okay, I was like, where are you getting that? Okay, good. You sorted out your own issue there. So the domain for g is going to be x greater than or equal to 0 because it has to be positive values. So that's one thing you want to think of when you see square roots. We have to think positive values. Now, ultimately, the directions, what are their domains? What we really want to know is the domain of f plus g and the domain of f minus g. That's what we're really being asked. So domain of f plus g and f minus g. And I'm going to talk about them together here because they're going to be the same. The idea of the domain of f plus g and f minus g, you just have to put together any information we already had. If the domain of f is all reals and the domain of g is all reals, then guess what? The domain of f plus g and f minus g is all reals. Now, what about the domain of f plus g? Can it be all reals? No, because look, what does f plus g have in it? It has a square root. So if it has a square root in it, it can't be all reals. So what are we going to want to use for our domain of f plus g and f minus g? It has to be the positives. So x greater than or equal to 0. I feel like Math Excel, it's more of a multiple choice type domain question, but I still want you to be familiar with the idea. Okay. I want to, on a normal day, I just keep going, but we're going to jump down to C, if you will. Can you handle some skippage? If that's a word. It's a word in my vocabulary today. Let's talk C. What's different about C?
X squared.
Exponents, but what are we being asked to find?
X.
We're being asked to find f times g and f divided by g. So, that's why I skipped B. I want to talk about multiplying and dividing since I'm not here tomorrow. So, f times g. I skipped down to C. Everyone caught that, right? Whether you're writing in the right spot or not, it's a whole other story. But f times g. What is f? F is x squared minus 9. What is g? X plus 3. Technically, what needs to be around both of those binomials? Parentheses. Okay. How do I multiply these? FOIL. Math Excel is going to make you simplify it out. So we are going to FOIL this out. In other words, doing any simplifying you can. First, x squared times x is x to the third. Add your exponents. When you're multiplying, add your exponents. X squared times 3. 3x squared. Insides, minus 9 times x, minus 9x. And lastly, minus 9 times 3, minus 27. Is there any other cleanup I can do? Do I have any other like terms? No, no other like terms here. So at that point, we have done all the simplifying we can. That's f times g. Now we need to do f divided by g. F divided by g. Well, you know where to start, right? We're going to do f divided by g. What is f?
X.
X squared minus 9 divided by g. What is g? X plus 3. Now, okay guys, here's the catch. As this is right here, we can't simplify this. Okay? As this is right here, we can't simplify. No, you cannot just go, oh, 9 divided by 3 is 3. X squared divided by x is x. It doesn't work like that. Okay? If you have two terms being added or subtracted, top or bottom, especially both, remember those terms that are added subtracted are married together. They can't just randomly cancel parts of them. However, x squared minus 9 factors. And that's how we need to do our simplifying here. Any remembrances of how x squared minus 9 factors?
Minus 3x plus 3.
Yeah. X squared is a perfect square. 9 is a perfect square. It's kind of like product and sum, except it's one of our special cases. X squared, the square root of x squared is x. So the front of each parenthesis is x and x. The 9, the square root of 9 is 3. So the back of each parenthesis is 3. How do you multiply to get a minus 9? Yeah, a positive and a negative, or a negative and a positive. What was my denominator already? It was x plus 3. Hey, what just happens to happen? Yeah, that x plus 3 will cancel with x plus 3. What's my remaining answer? X minus 3. Guys, in those division problems, watch for the factoring and canceling. It will happen. Now, domain real quick. I want to get to the back side if I can. Okay. Look at them individually. Domain of f. Are there any restrictions to what I can put into f, what I can square and subtract 9 from? No. You can take any number you want and square it and subtract 9. So domain of f is all reals. Domain of g. G is x plus 3. Is there any number you can't add 3 to? No. You can add 3 to any old number. So the domain of g is all reals. Now, this is where we have to be careful. If we were just adding and subtracting, our domain is all reals. You add all reals, you subtract all reals, your domain is all reals. I have to look at these individually. What about when I multiply? When I multiply f and g, did anything really change here? No. All reals and all reals, I'm multiplying those. I can still use any number I want in there. So my domain of fg is also all reals. Okay, so that is domain of f times g. Now, you know it's coming, right? There's a catch, yes? Otherwise, Mrs. Sargent wouldn't be breaking this up into so many pieces. Domain of f divided by g. F divided by g created a fraction, yes? What was in the bottom of this fraction right here? X plus 3. What is true about the denominator of a fraction? It cannot equal 0. What value would make x plus 3 equal 0?
-3.
Negative 3. And here's what I'm going to tell you guys to do, is I'm going to tell you, take your denominator and set it equal to 0. Even though it ended up canceling, we had that denominator at one point, yes? So if I set my denominator equal to 0, my denominator was x plus 3 equals 0. How do you solve that basic equation? If it's x plus 3, I'm going to subtract 3. And that tells me I get x equals negative 3. And guess what that is? X can actually not equal negative 3. So that's an exception there. And so what I'm going to say for my domain of f divided by g, it's all reals except what value? Except x cannot equal negative 3. Sorry. Okay. So all reals except x cannot equal negative 3. Okay. Watch for the division, the catches there. Okay. Now, I know it's not going to be very much time, but I want to look at the backside real quick. Because I'm not sure how this is going to go over via a video, but we'll get it all sorted out later this week. Just, okay? I'm not going to try and leave you in confusion, but we'll get it all sorted out. Composing functions. This is what you watched a video on, okay? And being asked to find, I call this fog and Goff, okay? I don't think the video used fog and Goff, but f composed with g of x and g composed with f of x. The idea of f composed with g, you're putting g into f. G of f of x, you're putting f into g. Can I maybe get an example in here? If I look, we'll see if I can squeeze one in. I'd hope for a little bit more. G composed with f at negative 3. First of all, realize that is g of f of negative 3. Okay, that's by definition. G composed with f is g of f of negative 3. Always start on the inside. Do you know what it means to find f of negative 3? What are you going to do? You're going to take negative 3 and put it where? For x in the f equation. What is the f equation? X minus 5. What am I going to do instead of x, though? Negative 3 minus 5. What is negative 3 minus 5? Negative 8. Now, that replaces f of negative 3, yes? What is still out there? There's still a g out there, isn't there? Okay, so I did the inside, f of negative 3. I got negative 8. Now, g of negative 8. What's that say I'm going to do? I'm going to take negative 8 and put it where? Into g. What is g? X squared in this problem. So what's that say I'm going to do with negative 8? I'm going to square it. And negative 8 squared is 64. Okay. Look tomorrow. I will have all the information on schools and whatnot. But look tomorrow to finish some notes via video and to work on Math Excel. And I will clean up any messy disasters on Wednesday. Sound good?